Yeah, here's a Rohde Schwarz audio signal generator. Well, actually, it's not audio, it goes from 1 hertz to 1.3 megahertz. But I've used these before, they're scarily accurate and very good pieces of kit actually. And you can get them on eBay for as little as 100 quid sometimes. But the customer sent this in, it's blowing fuses. You can see there's the case. Actually, the case is upside down because I think he's had the screws out and looked inside, which is always a bad sign because I don't like things that have been messed about with or done by other engineers. But there you go. So fuse is blowing, so I'm just going to whip out those screws down the side there on both sides, and then we'll have a look and see what happens. I have actually connected it to the test rig, and yeah, it is input's almost a dead short. So it's current limiting on the AC side, so there is a fault, probably a power supply fault. So I'm going to whip the case off and have a look if you're interested. If not, go to a different channel. Okay, covers are off and here it is. This is the bottom side. Top side, top side. Yeah, so we've got all the electronic units here. Frequency processor, usually there's a source, a multiplier, a PLL synthesizer, and then an attenuation board in these things. They're quite good. They don't give much trouble actually. But the yeah, there's a strange. I've done a couple of these before, but there's a strange kind of crystalline build-up. I don't know if you can see that on there very well. Maybe I'll zoom in. But you've got your toroidal transformer. You've got these caps here, aluminium caps, and they're the aluminium outside external body caps, which are the screened caps. So if you're gonna connect an alternative capacitor, you really ought to make sure it is one of the screen type. These, I'm pretty sure, will have the screen connected to the, or the metal can connected to the negative connection on the capacitor to provide screening. So really it's an electrostatic shield to what's going on inside the capacitor. Yeah, so weird, down on this capacitor here, I don't know if you can see this, I'll try and zoom in on this, if you bear with me a second. Where are we? There we are, we might need to go to a special mode. Okay, well, the case is off. We've got the frequency processor, the source, the synthesizer, and underneath, I think, is the is attenuation to get the precision attenuation as well. Done a couple of these, but a long time ago though. I can't quite remember what's inside, but got the fan obviously, toroidal transformer, smoothing capacitors, power supply regulators, heatsink on the back, general power supply stuff. What is interesting about this one is a kind of crystalline build-up of deposits inside, and it's sort of in the, it's obviously been in an environment where something has been in the air, and there's all this whiskery stuff that looks a bit like snowflakes. You know, when a crystal's growing you get all those little tendrils coming out of regular patterns. Anything worthy of note really. If I zoom in a little bit, so look at these caps. So these are probably the ones with the screen cases. So in a precision equipment, these tins are connected to the ground to provide electrostatic shield against any activity inside the capacitor drifting out and affecting the precision generator electronics. But generally speaking, I don't know how old this thing is. It's German. It's Rohde Schwarz. Rohde Schwarz, yeah, it's very good. Not sure. If I find a date, I'll let you know. But there's a top 23 transistors and all bolted onto heat sinks the old-fashioned way. But I'm going to pause for a second. I'm just going to zoom down on this cap and show you what's under there, because it's quite interesting actually. So I'm going to stop and then put it in macro focus, macro zoom. Yeah, that gives you a pretty good indication of the kind of tendrils of chemistry or deposits that have been going on. So I don't know whether that's salt or what it is actually, but I haven't really seen that very much before. It's a deposit of something that's driven by the electrostatic field on the components, I think. Certainly the plastics have got it all over it. So I'm going to go and take this outside and probably blow it out with the airline and then disassemble it. So before I do that, I'll just show you the underside. Yeah, where's the underside of the thing? Fine. I'll zoom in a little bit more so you can have a better look. Nothing particularly special. Got a long rod actuated switch, which I've just sprayed with some contact lube because it was really grouchy. I actually did wonder whether the short might inside the switch because it was so grouchy, but it's freed up and it isn't inside the switch. I have had these things. This is a combined input filter stroke IEC input mains and voltage adjustment, and I have seen these on some bits of test equipment where the internal capacitors inside have blown up and gone short. So, you know, before you start poking around disassembly, make sure if there isn't a short inside the mains input socket stroke filter, because I've seen them blown up quite often, especially on Wayne Kerr equipment and Schlumberger Solartron as well. Used one in the 70s, particularly on their multimeter range, and they often go short circuit as well inside the actual mains connector, so you have to take the whole mains IEC input fuse holder stroke connector filter block out and chuck that away. So before you start poking around, check that first, but in this case it's not that, it's something else. So I was going to take it apart and see if I can get access to some of these components and try checking them and see whether it's anything that's particularly obvious. So yeah, next time you'll see it, it'll be in bits. Yeah, I had second thoughts about that. I spotted this row of power devices bolt onto a heatsink. 7924 is a -79 series. That's a 1 amp minus 24 volt regulator, fixed output. Good devices. Next one's a 7824, so that's a 78 series. That's a positive 24 volt regulator. And then we've got a, what's that one? Ooh. No, don't recognise that. VN66AF. Don't know what that is. I'll have to look that one up. But in the meantime, I'll check these regulators first, and then I'll have a look. So this one, I'm on diode continuity, so it's a couple of volts forward voltage, and I can see that rising as the voltage, as the meter is charging up the output capacitors. So there's not a short on that rail. That one is reading, yeah, it's climbing. It was 0, but it was a discharge capacitor, and now that's the input capacitor to that regulator, and that's climbing. So there's no dead short. It doesn't say there's not overcurrent, but there's no dead short. And then this one, this is the input side. Yeah, that one's detecting the output transistor. I'll swap the probes over. Oh. Yeah, that's reading about half a volt, which doesn't really translate into any impedance as such. It would do if you knew which current the meter would put out, but I don't know what it is. We would calculate it otherwise. And then on the input side, right, that's reading a dead short. 0 volts. Can't raise anything across there. So if I put it on ohms, we can actually measure the resistance this time. And it's dead short. It's actually 0.3 ohms, which is the same. Yeah, it's the same as the probes. So that's absolutely dead short across that device, which is the 24 volt positive rail regulator. And the middle pin is ground, so that's shorted to ground, or 0 volts, not ground, but 0 volts. So that could be the culprit. It might be something on the output side, the output capacitor, for example. There'll be a reservoir capacitor on the positive output from this to decouple any noise from the board and to stabilize the output. So it could be that that's gone shorted, or it might be something else in other regulation circuits that's gone short circuit. I'm going to have to poke about, but it could be possible to change that regulator without removing the whole assembly, but it might be useful just to remove the regulator from the top side and then inject a voltage into the board and then see whether the short is removed, or externally test this device with a load resistor and a power supply to see if this device is working or not. It's certainly going to be an easy option because taking these apart is quite an involved process. There's lots of stuff to remove to get the chassis to explode and open up so you can get to things. And of course when you're taking all this stuff apart you have to be extremely careful, because after all it is a calibrated device, and strictly speaking you should calibrate it. I can test it with my other equipment. I've got some pretty good Agilent and HP equipment here that I can check it with to make sure it's working properly, so that's adequate for what my customers are going to use it for. But yeah, I'll investigate further and I'll be back. Right, anyway, so got this board out. Actually I forgot that you can take the screws out the back and then plug one of the regulator boards out, so I unplugged the regulator board and I'll remove this little chappy here, made in Korea, the 20 plus 24 volt regulator IC. Yeah, so I removed that, and this isn't shorted, so it's not the device that's shorted. And when the board is unplugged, the short is gone, so the short's not on this board. Pretty sure about that. So I'm going to put that there, I'm going to put that back and test it in a moment. So time for a poke about on the main unit, I think. So if we zoom out slightly, there you go, my lovely wooden bench. And grab this doofer. Right, so what can you see? What can you see? Ow! Something's got some power in it. Yeah. So looking down that hole there, you can't really see much. There's stop and great transformers in the way. What I can see down here in that part are 4 rectifier diodes arranged in a bridge just right underneath the transformer under there, basically. Just take my word from it, they are there. And then you've got these, interestingly, 2 capacitors. What voltage are those? So these two Johnnies here are 1000 microfarad, 40 volts. So, and they are arranged in a, my head in the way of the light. Yeah, they are plus and minus, so that's probably the plus and minus 24 volt smoothing capacitors. There's a 10,000 microfarad, 10,000, made in German, made in the fatherland, 10 volt, or 10%, so it's 10,000 microfarad, 10%, 16 volt. So that's not going to be a direct connection to our 24 volt rail. And this other one here, there's another 2 of those. Let's see what they are. (2,200 microfarads), and the voltage is, can't tell what the voltage is at the moment, but I'm guessing, oh look, they're down there, there are, oh yeah, there's a 7915 and a 7815, so there's a plus and minus 15 volt rail on here as well, and there's 2 other devices on there, I can't see what they are. So I'm guessing that this is the 24 volt rail, the unsmooth 24 volt rail, so they're the basic power supply smoothing of the 24 volt rail there, that go to those 7915 and 7924 and 7824s on the regulator board that we took apart. And this one's for the 5 volt rail, so it's a big capacitor for the 5 volt rail. And then these 2, I'm guessing, are the plus and minus 15 volt rail smoothing capacitors, or reservoir if you want to call them that, for these 2 regulators. So my guess is that one of these 2 has gone, or it's going to be the bridge rectifier, and let's just hope it's not the transformer. I should think if it was a transformer we wouldn't see a direct short on the output side, on the input side, because it's gone through the bridge rectifier, but you never know. If it's been struck by lightning or something, it might be the case. So whip it over and remember where they are. How's the focus doing? Right, so does that pull out? Yeah, it does. Okay. Alright, so I'm going to put a prop clip on here to hold this out of the way for you. I'm going to unplug it all, so I'm just going to crocodile clip it. Crocodile. Right, okay, so is that in focus? Do you know what? I'm going to have to get an HDMI cable for this rig. Okay, so yeah. So we are here. Here's our bridge rectifier. Look, there are 4 diodes in a row. So are we on peak? So we're again on just ordinary forward short mode. First off, oh, that doesn't look good. That's shorted. That's connected to that one. That's shorted. That's the 24 volt rail unsmoothed. So that's the unregulated 24 volt supply. It won't be 24 volt. It'll be a bit higher, won't it? So that's shorted. Alright, and is that the capacitor there? Yeah, dead short on there, that's the cap. And then I think this goes through to supply these two plus or minus 15s on the back unit. So it could be one of those shorted. But if we just put it on ohms, on 200 ohms, and measure across this diode, interesting. Put the meter on correctly, it helps. Yeah, I've got 3.7 ohms on that one, 3.9 ohms on that one, and 7.6 ohms, which is a transformer winding. So it's a centre tapped plus or minus probably 20 volt AC or less than that 18 volt AC transformer going through a bridge rectifier and then giving out 2 rails plus 24 and minus 24, and coming to this capacitor, which the capacitor is measuring dead short. So a dead short across the capacitor and 4 ohms showing across the diodes, which is a transformer winding. So it's looking like the cap or the 7815, the plus 15 volt linear regulator. Now I don't know whether that's fed from the 24 volt, so it goes from unregulated 24 then to 15, or whether it's fed from another winding. But there isn't another winding because there's only one bridge rectifier. So I think what I'm going to do is I'm going to drop that cap out and then do a test with that cap before I do anything else, just in case it's just that. So back in a bit. Yeah, before I take this cap out, I can't see the case or the orientation or the polarity, and there's no component markings on this board. In a German fashion, you haven't got the drawing, you can't fix it. So I'm just going to put an arrow on there pointing to the back of the unit. And I know that when I put it back, if it's good and I have to put it back, I know which way it goes in. And you can't really see that, but there is an arrow on there now. So I know which way it goes back. So it's this one here, anyway, is the one that's got to come out. And if that one's blown, I'm probably going to change while I'm in here. All 3 of them, I should think, or 4 of them. So anyway, it's in a bit. Right guys, there you go. So I managed to get it out. What a struggle that was. I don't know if you can see that. It's got 3 pins on this screen cap. It's a very special cap, that. It's got a outside 3 metal pins and then a big central pin. Hold on a minute. Lunch is ready.
Sorry. How long do I defrost these for?
In the microwave? About 10 minutes, but on defrost. That was the lunch on its way. What was I saying? Yeah, special cap anyway. So let's just check it, make sure our diagnosis was correct. Yeah, it's 1000 microfarad 40 volt, Germany. See that? Germany. Not so clever after all. West Germany. So it was before the wall came down. And the make is ROE. ROE. Yeah. Anyway, so it's short. So I'm going to find. Question is, if you put a normal cap in, is it going to radiate? And is it going to cause a problem with the generator, or is this just German over engineering? Or can I get a screened capacitor with that voltage and pin out? That's a good question. I want to look on the internet. Back soon. Well, I'm back from about half an hour of web browsing, and yeah, it may have been special. I see Rohde, as a German company, is now owned by Vishay, and the DIN 41253 really just is general purpose aluminium capacitor with this mounting arrangement, which is quite good actually. You know, probably use it in missiles or something, so to survive the G-on launch. But clearly it's billed as a low ESR capacitor, so it's good at what it does, as effectively the series resistance is pretty low. But having said that, it may have been good in its day, but it's certainly nothing special now in terms of its performance. In fact, they're about, you can still buy them for $4 or $5 each, and I've just ordered some from eBay Canada. I've ordered a bunch of them because I thought it might be useful to have in stock, because there's bound to need to change some more at some point. But whether they're vintage stock and whether they're any good or not, that's something else. Don't know really. But anyway, Rohde capacitors, and a lot of people, you can Rohde gold label, this Kapton label they put on it, is all the audiophiles love them, you know, super high, you know, filter capacitors, blah blah blah. But in the end of the day, they just look at it pretty. But you know, Panasonic and Nippon Chemicon make perfectly good capacitors with the same ESR, same electronics performance. So you know, they're paying premiums for not very much at all. But anyway, what I'm going to do is to stick a standard one in for now and test the unit, and then wait for the real stock to come in, i.e. these things. Put them on the tester. I've got quite a nice capacitor tester, a Wayne Kerr one, and yeah, we'll test the new ones when they come in and see if they're any good or not. But yeah, that's what's wrong with it. So I'm going to put it back together when I put the capacitor in. Yeah, look at this. So same capacitor, same value, same voltage, but much smaller than the modern one. Much smaller, much less volume. And I've checked this out, and the negative line for the capacitor, the connection, is not connected to the CAN, so this isn't screened. And I'll have a look online, see if I can find some screen ones, but generally speaking they're not. So debatable whether it needs to be screened or not, but I noticed the transformer's fully screened inside that unit as well. So I'm going to put this in, test the unit, make sure it all works, and then when the proper cap comes in, these things come in, I'm going to test the caps, and then I'll fit the real thing in the meantime. But I just thought you might find that interesting. Okay, so the covers are back on this thing, and I've connected the output into the input on the counter timer. Let's hit the button there, counter timer on. Probably need a filter on, and then we'll hit the power. We'll see what happens. Contact. Ooh, it's looking good. Spelt hello wrong, so it's not working properly as far as the English are concerned. Slurp of tea to celebrate. What happens next? Oh, it's counting down. I'm guessing that's because the crystal oven's warming up. There you go, 10 kilohertz. We've got an output level of 1 millivolt. That's the resolution, the minimum. You can also set the output in dB, dBm, referent to 1 volt. But let's put 500 millivolts. There we go. Oh, there you go. Ah, on target. So yeah, 10 kilovolts, 10.000 out here, 10.000, and actually it's 0113, so we're down to 1, 2, 3, 4, 5, 6 significant digits. I'd say that is pretty close. Let's try kilohertz, 1.0 kilohertz. There you go. How's that? That is close. That is close. And then let's try 50 kilohertz. Yep. It's within 0.05 hertz of 50 kilohertz. And then let's try 1 megahertz. There you go. 1 megahertz. So you got 6 0. 1, 2, 3, 4, 5. Yeah, it's 1 hertz out at 1 megahertz. I would say that is working. I'll check the calibration on the analyzer there. That one. That's calibrated and measure that can measure up to 50 kilohertz voltage, but I'm not expecting any problems. Quite a nice machine actually. You've got 55 ohms and a maximum output of how many volts? Let's see how many volts this thing can do. 5.0 volts. Yeah, it can do 5 volts. That's quite good. That's respectable. 10 volts. Wow, 10 volts. So if you think if you're driving into a 5 ohms, that's quite a powerful output stage on this thing. So yeah, a nice piece of kit, useful for testing audio and things like AM and long wave radios, or just generally getting a square wave. But it is very accurate, probably more accurate than you need for audio. But you know, it's a good thing. And if you see one of these online, snap it up because it's a fantastic piece of kit when it's working. So that really concludes the repair. That's done. I'm going to do the voltage check and just check the calibration of the voltage, but the customer doesn't really need it calibrated, but this is calibrated, and that's working pretty close. So let's go back to 1 kilohertz again. I like that. There you go. Sorry, that was kilohertz. 1.0 kilohertz. There we go. There you go. It's warmed up slightly, drifted off, but it's pretty close to the stated amount. There you have it. So bad capacitor. This thing in my component graveyard was the culprit. Looks like it should last 100 years based on the construction and the fact that they've stamped the fatherland on it, but no. I don't know what age this is. I think this was made in the early 90s, this machine. So, yeah. There you have it. All done. Done and dusted. Thanks for watching. If you like the channel, then subscribe. There's lots more repair videos coming on. If you've got any questions, drop me a line. If you want one of these fixed or need any advice, happy to help. So take care and thanks for watching.